An anonymous and pessimistic philosopher has said 80% of your final exam will be based on that one lecture you missed or that one book that you didn't read. Hi, I'm Arjun Bhagat. Well, Topper would advise you not to be so pessimistic, but we'd surely tell you to be very thorough with your syllabus before entering the examination hall. And that will be our attempt in today's exam special show as we take up the topic electrochemistry. We'll trace the exam trends, practice probable questions, and I'll give you certain exam tips that'll keep you well ahead of the others. To start with, let's go trend spotting.
Let us start with the weightage of this unit. Electrochemistry carries a total of 5 marks out of 70 in the chemistry paper. That is 7% of the total marks. Now, we can expect a 5 marks long answer type question in the exam from this chapter. That's a general trend being followed.
I'm sure that'll help you make your revision more exam focused. We'll soon get on with practicing questions that you could expect this year. But before that, let's quickly recap the main concepts you've learnt in school from this unit.
In this chapter, we have already learned Nernst equation, molar conductivity, Colruyt's law, Faraday's first and second law of electrolysis, and the reactions taking place at anode and cathode for dry cell, lead storage, battery and fuel cell.
Nothing new, concepts that you're already familiar with. But it was important to quickly refresh your memory because without too much delay, we'll start our practice session. Before that, let's quickly see which ability the examiner will be testing you on while you answer questions from this unit.
Analysis of the question papers reveal that mostly numerical problems and a few knowledge-based questions are asked from this chapter.
Now we are all set to practice probable questions. After all, practice makes perfect. Coming your way, first a model question. Keep your eyes and ears open while you answer this because if you get the process right, you're ready to answer any question from this unit.
Here you're supposed to calculate the EMF of the cell whose oxidation half consists of solid magnesium and magnesium 2+ ions separated from the reduction half by a salt bridge. The reduction half is made up of copper 2+ ions and solid copper. We are given that standard electrode potential of copper is plus 0.34 volts and that of magnesium is minus 2.37 volts. And also explain with examples the terms weak and strong electrolytes. The first part of this problem is numerical, which requires the application of formula. This is an average question worth 5 marks. The second part is a direct knowledge-based question from the topic Types of Electrolytes. The key to solving this numerical correctly is to proceed in a stepwise manner. In first step, write the balanced cell reaction. The second step is to calculate the standard cell potential. Be very careful while calculating this. Take the reduction potential of the reduction half cell minus the reduction potential of oxidation half cell. Also correctly identify the oxidation and reduction half cells. E0 cell comes out to be equal to plus 2.71 volts. This will get you 1 mark. Next to this, write the Nernst equation, which if done correctly, will fetch you another 1 mark. So substitute the values and solve for the value of cell potential. The Nernst equation for the cell EMF is E cell equal to E0 cell minus 0.059 divided by N multiplied by log of magnesium ion concentration divided by the concentration of copper ions. Now substitute the values in the Nernst equation and solve the equation. The value of cell potential comes out to be 2.651 volts. For this answer, you will get 1 mark. Coming to the second part of the question, where you have to explain the terms weak and strong electrolytes. So, the electrolytes which are not completely dissociated into ions in solution are called weak electrolytes. Examples are acetic acid, ammonium hydroxide, hydrogen cyanide, etc. And the electrolytes, which are completely dissociated into ions in solution, are called strong electrolytes. Examples are hydrochloric acid, potassium chloride, sodium hydroxide, sodium chloride, etc. After answering both parts correctly, you will score 2 marks.
Practicing questions is the best way of revision. During the process of answering a question, you can gauge what you know and what you need to know. So without much ado, let's dive straight into our segment, Practice Makes Perfect.
Here we are told that 3 electrolytic cells, A, B and C, containing solutions of zinc sulfate, silver nitrate and copper sulfate respectively, are connected in series. A steady current of 1.5 amperes was passed through them until 1.45 gram of silver was deposited at the cathode of cell B. So you need to find that how long did the current flow and what mass of copper and zinc were deposited in the concerned cell. This numerical problem is worth 5 marks, and our judgment meter rates it as a difficult one. After going through the question, first of all, we will write a balanced equation for the electrode reaction involving deposition of silver. Atomic weight is equal to 108 grams. This is written to calculate the number of electrons involved in the reaction. Since the number of electrons gained by silver is 1, we get the electricity required to deposit 1 mole of electrons or 108 grams as 96500 coulombs. This will fetch you 1 mark. Next step is to calculate the electricity required for deposition of 1.45 grams of silver. This comes out to be equal to 1295.6 coulombs. Here you get another 1 mark. Now, to calculate the time required to deposit 1295.6 coulombs, we use the equation Q is equal to IT. Hence, the time comes out to be 863.73 seconds. Calculating the time correctly will fetch you a mark more. Since the number of electrons gained is 2 in case of copper, the amount of copper deposited by 1295.6 coulombs calculated 0.426 grams, so you score 1 more mark. Similarly, the amount of zinc deposited is equal to 65, which is the atomic mass of zinc multiplied by charge, that is 1295.6 coulombs, divided by number of electrons gained, that is 2 multiplied by 96500. This comes out to be 0.436 grams, and thus you get the final mark as well.
Now that you've warmed up, let's keep the momentum up. Keep your eyes and ears glued to the television screen. Here comes another question.
The second practice question states that the resistance of a conductivity cell containing 0.001 molar KCl solutions at 298 K is 1500 ohms. You have to tell that what is the cell constant if the conductivity of 0.001 molar KCl solution at 298 K is 0.146 multiplied by 10 raised to the power -3 Siemens per centimeter. This is a numerical ability problem that was asked in 2006 CBSE exam. It carries 2 marks and is an easy one. So, from this question, we know that the resistance of the cell is equal to 1500 ohms. The conductivity of the potassium chloride solution is equal to 0.146 multiplied by 10 raised to the power -3 Siemens per centimeter. And its molarity is equal to 0.001. Here you have to recall the formula which gives you the relation between conductivity, resistance and cell constant, and substitute the value in it to get the answer. We know that cell conductivity can be calculated by dividing the cell constant by resistance. On substituting the given values, the answer comes out to be 0.219 per centimeter. Don't forget to put the units after writing the answers.
For more such practice questions, you can always log on to our website www.topperlearning.com. Here you'll find sample problems, their answers, expert guidance and lots more that'll keep you ahead of all the others. Let's take a quick break now, but coming up after the break, more practice questions, the HOTS problem and some exclusive exam tips just for you. But just so that your brain keeps ticking, here's a question that'll keep you busy till we meet on the other side of the break.
You need to tell that why limiting molar conductivity for acetic acid cannot be determined experimentally. This conceptual question appeared in 2005 exam for a mark. It's easy. Try and seek the answer. I will see you after the break. Before the break, we asked you that why limiting molar conductivity for acetic acid cannot be determined experimentally. Well, in the answer you should write that limiting molar conductivity of weak electrolytes keeps on increasing with dilution and does not become constant even at very large dilutions. Since acetic acid is a weak acid, so we cannot determine its limiting molar conductivity experimentally.
Well, before the break, we solved a model question based on Nernst equation and did a couple of practice questions related to conductivity where we found the cell constant value. So let's continue with the practice question. Here comes another one.
Well, in this problem, we have to explain with an example that how weak and strong electrolytes can be distinguished. This question was asked in CBSE 2007 and is worth 2 marks. It tests your conceptual skills and is an average one as per Topper's difficulty meter. So, to answer it, we will write that the strong and weak electrolytes can be distinguished from each other by measuring their molar conductivities at different concentrations. The molar conductivity of a strong electrolyte increases slowly with dilution, while the increase in molar conductivity of a weak electrolyte is very steep at infinite dilution, or near zero concentration.
Numericals are a personal favorite with me. They are pacey and they are fun, but a sound knowledge of equations and theory is very important. So now let's test our knowledge of equations in the next problem.
In question number 4, you are required to write the chemical equations for all the steps involved in the rusting of iron. Also give any one method to prevent rusting of iron. This question was asked in the CBSE sample paper of 2008 and is worth 2 marks. The difficulty level is average and it tests your knowledge ability. Well, since we know that corrosion is an electrochemical phenomenon, so first of all, write the oxidation reaction taking place at the anode. Next to this, write the reduction taking place at cathode. And then write the overall redox reaction by balancing the number of electrons. Ferrous ions so formed move through the water, come at the surface of iron object where these are further oxidized to ferric state by atmospheric oxygen and constitute the rust, which is hydrated iron 3 oxide. Writing all the balanced equations correctly will fetch you 1.5 marks. Now, in the second part of the question, you should mention that rusting can be prevented by galvanization. In this process, the surface of iron is coated with a layer of zinc, which is a more active metal. Writing any one process to prevent rusting will fetch you half a mark. And thus, you'll score full on full.
That was the last practice question. Coming up, a HOTS question. While answering a HOTS question, you're required to use your high-order thinking skills. This segment was added by the CBSE to encourage students to explore rather than learn by rote. Let's now take a look at this question.
In this problem, you have to calculate the standard cell potential of the galvanic cell, in which the reaction you can see on your screen takes place. The reaction is twice chromium solid plus thrice of cadmium 2+ ions gives twice of chromium 3+ ions plus thrice of cadmium solid. Also calculate Gibbs energy of the reaction. This problem carries 3 marks and is rated as difficult on the judgment meter. It tests your numerical skills. Now, concentrate on the solution. From the given reaction, we will first write the cell equation. From this cell representation, we can calculate standard cell potential. That is, E0 of cell by using the formula E0 cell is equal to E0 right minus E0 left. This comes out to be plus 0.34 volts. For this, you will get 1.5 mark. Now for calculating Gibbs energy of the reaction, first of all, we will write the half-cell reaction. From the half-cell reaction, we come to know that the number of electrons involved in this reaction are 6. We can now calculate delta G. This comes out to be 196.86 kilojoules per mole. If you get that right, you get the rest 1.5 mark also. And remember that in a numerical related to electrode potential or Gibbs free energy of a reaction, always write the cell representation and half-cell reactions very carefully, because all the calculations are based on them. And in such questions, always take care of the signs. Now, note down a similar question based on this topic and solve it when you're free. Here you need to write the cell formulation and calculate the standard cell potential of galvanic cell in which the reaction visible on your screen takes place. The reaction is iron 2 positive aqueous plus silver positive aqueous gives iron 3 positive aqueous plus silver solid. Also calculate Gibbs energy of the reaction. We are given that electrode potential of silver is plus 0.80 volts and that of iron is plus 0.77 volts and Faraday's constant.
There was a lot of practice and I'm sure by now you feel confident to face any question from this unit. What would you say if I said I'll give you certain exam tips that'll keep you ahead of all the others in your forthcoming exams? And icing on the cake, wouldn't you agree?
This chapter contains a number of cell reactions and their representations. So practice all the cell reactions and diagrams on paper. Then, in the numericals related to electrode potential or Gibbs free energy of a reaction, always write the cell representation, half-cell reactions and signs of the electrode potentials carefully, because all the calculations are based on them. And lastly, the entire cell process can be remembered as lone, left oxidation, anode negative. So don't confuse between the two electrodes and the type of reactions related to them.
The last and most important tip would be do your best in the exams and leave the rest to the examiner. After all, if you've got everything right, nothing can keep those good marks away from you. See you in another episode of Toppers Exam Special. In the meantime, study hard and study smart too. Take care and goodbye.